In this video, I'd like to continue our discussion from class today and discuss 4 different types of problems that you might see in the homework part 2 that you work on this week and into next. The first type of problem that I'd like to work through is from the problem numbers 1 through 3 on the homework assignment. It's about classifying numbers. I chose to walk through this one because it's interesting. Down here you see that there are at least 4 or 5 parts to this problem. There are 4 remaining after this. Now, even though there are 4 or 5 parts to this problem, it's still only worth 1 point out of the homework set. But as you get to working through these problems, as you continue practicing them, you'll see that they do go very, very quickly. And even though this problem has multiple parts, the entire question is listed at the top of the problem here, at the top of the question. It asks us to list the numbers in the given set that are A, natural numbers, B, integers, C, rational numbers, D, irrational numbers, and E, real numbers. Now, since we're trying to classify numbers, we want to use the most specific classification for any type of number. And in this case, the numbers that can be represented by the term natural number are what we're looking for now. You should remember that natural numbers are sometimes called counting numbers. They are the digits that have no decimals or fractions associated with them, and they must be positive, greater than 0. So in this list of numbers up here, in our original list, -4 is not a natural number because it's negative. It's not allowed to be negative and considered natural. For part B, 4/9 and -4 are both non-natural numbers, and we can go through that whole process and ultimately decide that option C is the only pair of numbers in this original set that are natural. And so we'll check our answer for this part, and we'll see that we got that correct. So we'll move on to the next. And the second part of the question asks about integers. Which of the set are integers? So that's part B of the original question. Integers are the same as natural numbers, only this time we allow negative values. So A won't work because we have decimals here. B won't work because of the reduced fraction. 4/9 doesn't fit. But C does work. We have integer values here. D does not work, so I'm happy with C as the answer. We can check that and move on. Rational numbers. Rational numbers include natural numbers, integers, among others, and we also don't mind fractions. Fractions are considered rational numbers, and decimals that repeat themselves are considered rational numbers. But numbers that are not rational, called irrational numbers, are these Greek symbols if they represent a letter. Usually those are irrational. We know that pi is a decimal that continues forever without repeating, so that's not rational. But every option in D is, so we can make that selection and move on. So I'm not going to take up any more of your time to finish this problem. You see the process here. We just have to press continue through each part, and we're walking through just this one question, but MathXL has broken it up into all of the little parts for us. The second type of problem that I'd like to walk through is from the problem set numbers 4 through 9. This is a question of whether we should round or truncate a number, or what's the difference between rounding and truncating. So I'll come back to MathXL here. Now your screen might look a little bit different than mine since I'm doing this from instructor view. Oops, I didn't want to choose that. So if you're missing, let's see, I'm missing the question help options. I think your screen will display these help options for you on the right-hand side. But for me, I have to access that by pressing this drop-down menu. Now yours might look just like this, and that would be fine too. But I don't know if you'll have the ability to jump between questions. So I'm going to jump forward to question number 4, and I do want to leave this even though I only completed part of the problem. And you'll see here that this is another 2-part problem. We have a part A and part B. Part A asks us to approximate this given number rounded, and part B asks us to truncate the number to 3 decimal places. So if I'm looking at 16.4988 and I need to round it to 3 places, I look at this third decimal place, this 8 here, and immediately to the right of it, that's the value that helps me decide if this 8 should round up or stay the same. Since 8 to the right is greater than 5, we do want to round this up, so I'll go ahead and type this result in place. And we have 16.499, since the 8 rounds up to a 9. I'll press the Enter key to check my answer, and I see that that was done correctly. Part B asks us to truncate this value. Remember the difference between rounding and truncating. Rounding requires us to follow the rules to decide whether that value should change. Truncating means to simply cut off that decimal right where it is. So 16.498 should be the answer here. Right after the third decimal place, we just cut it off. So we'll leave that as it is. Press Enter to check my answer. And from here we can move on if we need to. Next, I'm going to pick a problem between 10 and 14 in the group. This is about writing statements using symbols. We're going to look at a word problem and rewrite it using mathematical symbols. So in this one, before I start answering it, I'd like to remind you that inside the question help options, you have the ability to look up problems like this in the textbook. So again, I clicked the question help option, and I'm going to choose textbook here. And this will bring up a new page, a new window for us to browse through. Now I had to resize the window to fit into this recording screen, but what you see is that this is basically the same textbook that we have in the classroom, only an electronic version, and we can jump through this as we need to. I'm looking at the objectives here in this summary box on this first page, and I'm going to look for an objective that's similar to the type of question that we're working on right now, and that is write the given statement using symbols. So when I look at these objectives, I don't know that that has anything to do with working with sets or classifying numbers, but perhaps evaluating numerical expressions. So I might jump forward to page 8 and maybe start looking around here to help me decide if I can find an example of how to write an expression using, or write a statement using symbols. And sure enough, actually right here at the top of the page, page number 8, we see the operations and symbols that we might use for those operations. But again, you might also know this too coming into the class. You might not have to look this up, but if you needed to, the textbook is available. And as you read through this chart or you start looking forward some more, there is an example just like that problem right here. So in this pair of examples, we have a written statement and we show how to write it using symbols. So let's go ahead and try to answer this other question. The product of 5 and y is the sum of 8 and 7. Now notice the special instructions here tell us to type an equation and do not simplify. So you'll get to the point here where you see the sum of 8 and 7 and you might want to actually simplify that part of the equation, but we don't want you to do that. So the product of 5 and y is what we will write first. Now product means to multiply, so we'll write 5 times y, and I got that dot by pressing Shift 8 on my keyboard, or if you have a number pad, you can just press the star button there for multiplication. Equals, for the word is, okay, the product of 5 and y, 5 times y, is the sum of 8 and 7. So 8 plus 7 for the sum. Again, don't simplify this. Don't add 8 and 7 and write your answer. That would be marked wrong. But if we leave it as it is, we can check our answer, see that we got it correct, and move on. Okay, I'm not going to use that book anymore, so I'm going to close that window. And I'm going to jump to a different problem. This time, we're going to look at one of the problems from the group 15 to 33, and I'd really like to outline the Help Me Solve option and the View an Example option. This will show you what you can do while working through MathXL if you get stuck. So you can likely very easily evaluate this expression, 4 plus 5 minus 1. You can come up with a result here. But let's suppose that we encountered something a little bit more difficult. And we can find something even more difficult than that. Here we go. Here's something that you might be thrown off at the beginning, especially if you don't have a calculator available to you. But what I want to point out that is available to you is under our question help options, we can ask MathXL to help you solve this problem or to view an example just like this. If you choose the help me solve this option, MathXL will pop up a window and show you how to complete this exact problem step by step. And what's nice about that is that it actually walks you through every single step that you should be thinking about while completing this, and it gives you the number of parts that you'll have to walk through to complete it. Now in this case it tells us that the order of operation tells us to begin with the innermost parentheses or grouping symbols. So the innermost parentheses here is the 2 minus 1. These are parentheses inside of the square bracket grouping symbols. So to simplify 2 minus 1, well, that's 1. So we'll write that as our answer. We'll check it, and then we can move on to the next part. Next, we simplify inside the outer grouping symbol. So that inner grouping symbol was finished. Now we have this outer grouping symbol, this square bracket. And the order of operation tells us that multiplication is done before addition, so we should complete the 3 times 4 before we add anything. 3 times 4 and the 2 times 1. 3 times 4 is 12. 2 times 1 is 2. We can check our answer and move forward from here. So you get the idea. It's going to walk you through this problem. Now I just skipped ahead here to show you what happens when you get to the end. So all of the parts are showing you've walked through, or it's walked you through this problem and you've gotten to the end. We found a correct answer, but when we close this, you don't get credit for that work. And in fact, you might have noticed that the problem then changes. So you don't get the point for completing that problem. You get to do another problem just like it now, and you can earn the point by doing it this way. What you'll see, though, is that the problem, the calculation approach really didn't change. It was just the numbers that changed inside the problem. So now, if you had all of those steps written down, as you probably should be doing on a scrap sheet of paper, then you've got that to look off of while you move forward. So that's what happened when we asked MathXL to help you solve this problem. If you click View an Example, it's very similar. However, you'll see this is an example problem that's different than the original. It too walks you through all of the steps. You can add these to your notebook while working through the steps so that when you complete this walkthrough, you can use that as a reference while completing the problem that was given to you originally. So I hope that helps you with the MathXL assignment just a little bit. I know it's a bit daunting to see how many questions there are to complete, but in this quick walkthrough, I'm sure you saw some problems that are very easy to complete, and you'll recognize that they can be done very, very quickly. This isn't meant to take up an extreme amount of your time. It is a review from your mathematical career so far in high school, and I think you should be able to complete this over the weekend. Be sure to email me if you have any questions, and I'll try to respond to you while you're working on this. This assignment will be due sometime next week. Thanks for watching.